This week's primary objectives include the use of proper safety practices, learning the basics of MIG welding, and assembly of a can crusher. Demonstration this week will be confined to the use of a MIG welder, as emphasis is placed on the student to use previously learned techniques and skills to assemble their project. Throughout the course of this semester, the use of many different tools will be required in order to complete your various lab assignments. The first step in using a tool correctly and efficiently is being able to identify it while also knowing its specific function. This week in lab, there are only two new tools that you haven't been introduced to. One is a metal inert gas welder, otherwise known as a MIG welder, and the other is simply a pair of welding pliers. PPE, or personal protective equipment, required for each lab can vary from week to week. It is important to stay up to date on the PPE to meet the safety requirements. The students' PPE for this week will include closed-toed shoes, long pants, a long sleeve shirt, safety glasses, leather welding gloves, a welding helmet, and a face shield. Materials this week will also be done slightly differently. You will receive one 3" by 3" crusher plate and another 4.5" by 3" crusher plate. For tubing, you'll need one 18" long piece of 1" tubing, another 13" long piece of 1¼ tubing, and a 2" piece of 1½ tubing. It will be your responsibility this lab to cut each piece to its proper length. While not all MIG welders in the lab look the same, they will all have the same basic controls: an on-off switch, a wire speed adjustment knob, an amperage control, a ground clamp, and a MIG gun. With the exception of flux core wire, a fundamental difference in a stick welder from a MIG welder is that a MIG welder uses shielding gas to shield its weld from atmospheric elements. Wire is fed from a large spool into a liner that then goes into the MIG gun. When the trigger on the gun is pulled, wire is fed all the way through and out the other end. Before beginning, make sure your ground clamp is secured properly to your welding table. Also, make sure that the gas is on. If the gas isn't on, the weld won't be shielded and it'll lead to an improper weld. And then, turn on your welder. To create an arc, no tapping or striking is required. Simply pull the trigger on your gun and the arc will start. When welding with a MIG, there's no need to push into the puddle because the machine is controlling the feed rate of the metal into it. Movement and arc length are the only two things controlled at the gun of a MIG welder. For movement, a half moon shape is being demonstrated here. And as you can see, due to the shielding gas, there's no excess debris that needs to be cleared off after we weld. One of the first mistakes you'll run into is accidentally pressing your trigger and bringing too much wire out of your gun. To fix this, simply grab a pair of welding pliers and clip off the excess wire. Another very common mistake is welding without shielding gas. If this occurs, the weld won't have any protection from atmospheric elements. This will cause porosity and a weak puddle formation, as shown. Just like with stick welding, moving too fast is another common mistake. This leaves a narrow puddle with little to no structural integrity. Next is too long of an arc length. With a large arc length, the wire begins to pop when it makes contact, causing small pieces of wire to become scattered around the metal. At a longer distance, the shielding gas has little effect because it can't properly shield the weld. With too low of a wire speed, we don't see a puddle formation. Instead, we see a large flame-like aura on our tip as the wire slowly melts in. Opposite of that is too much wire speed, which we see here tends to lead to an unstable puddle formation.